Okay, so our next lesson is going to be on three special parallelograms. So they're more specific names with even more specific properties. They're going to hold all of the properties of the parallelograms plus their own special properties. So we're going to talk about the rectangle, the rhombi, and the squares. Okay, so for rectangles, okay, so for rectangles, they hold all of the properties of the parallelogram. So they have the sides, the opposite sides being congruent, the opposite angles being congruent, the fact that the diagonals will indeed bisect each other. Okay, but they also hold some special properties of their own. So they will always have four right angles. Okay, so that's going to be those angles in the corner. The diagonals do not bisect the angles, okay? They are not cutting those angles in half. Please do not assume that they are, okay? They do not cut those angles in half. And some of the applications that you're going to use for the fact that it is a right angle, okay? You're going to use the fact that there are right triangles now. If you see ADC there, is a right triangle. So we're going to be having to use Pythagorean theorem, right? A squared plus B squared equals C squared. The other part you might have to use is to find that angle. So maybe you know the whole angle is 90 degrees, okay? And they give you part of it. So say this part, it's going to be bigger than that, was 72, right? You would say 90 minus 72 to find that second angle there that's missing. Okay, the second piece here of their properties, right? So they still have all those right angles. That is unique to the rectangle is that the diagonals are actually congruent. So if these diagonals are congruent, that means that AC is congruent to BD, right? But it also means that they hold that property of parallelograms, that they bisect each other. So that means all of their little pieces will also be congruent to one another. Okay, and here you're just going to set those diagonals equal to each other. Remember, sides again hold the properties of parallelograms where the opposite sides would be congruent. So please keep that in mind with your rectangles. The second shape we're going to talk about is the rhombus. Okay, so the rhombus holds all the properties of the parallelogram, okay, but it has specific traits for it as well. It's going to have four congruent sides. So that means all of the sides around the outside will be congruent to one another. Okay, and again, the only thing you can do with sides is set them equal. Please do not ever set sides equal to 180. That is angles. Diagonals are going to be perpendicular to each other. So perpendicular means there's a 90-degree angle formed in the middle of all of these angles. So there's a 90-degree angle here, there's a 90-degree angle here, here, and here. So those are all tiny right triangles on the inside of the rhombus. And they love to use that and ask you to find the length of the outside sides by telling you what the inside is going to be. The diagonals on the rhombus will bisect the opposite angles. So like I said on rectangles, how those do not bisect, okay, on rhombi they will. So the diagonals will bisect, creating congruent angles that are opposite of each other, okay? So those angles will be equal as well as the small angles of the other, okay? That will hold true there. As far as the diagonals lengths, they are just like the parallelogram. They bisect each other, but they are not equal like they are the rectangle. In reference to something outside of this that helped me remember the properties, the rhombus is known as the mom. Okay, it's like our little family. If we go back to that rectangle, it's known as dad. Okay, because they hold their own unique properties. And the parallelogram is the grandmother, right? The last shape we have is the square. The square is going to be the child because it holds all of the properties of grandma, mom, and dad. So it doesn't hold any of its own properties, but everything you can think about from all of the other shapes, the square holds. So it has those right angles in the corners, okay? Their diagonals bisect and are congruent. It has the right angles there in the middle. All of its sides are congruent, okay? Now, one thing they love to do here with squares is ask you what the given angle here is when you've cut these things in half. Now realize this is a 90-degree angle and it holds the property of the rhombus where it bisects the angles. So you're cutting 90 in half. So half of that angle is 45 degrees. So this angle here will always be 45 degrees for the square, okay, no matter what. And a lot of the times they like to ask you, find the value of x for that angle specifically. You're just going to set it equal to 45. You need to know that it's 45, okay? Let's look at some examples of how we're going to use these properties. So here it asks us to label the rectangle BASE, okay, BASE, and solve for A, EA, and SB. So I'm going to place my information where it needs to be. So EA is a diagonal, and it is 5A plus 4. Okay, and BS is also a diagonal. Let's make that red. And it's 3A plus 8. So it asked me what property am I using. This is a rectangle, so its diagonals are congruent. So that's the property I'm using. Okay, so if they're congruent, all I have to do is set them equal to one another. So 5A plus 4 equals 3A plus 8. I'm going to subtract 3A from both sides. I'm going to get 2A plus 4 equals 8. Subtract 4. So 2A equals 4, or A equals 2. So my A value is 2. In order to get my length of EA and SB, all I got to do is plug 2 back in there, and the lengths will be the same. So I don't really have to plug them in for both. I just really have to plug them in for one. So let's plug it into EA. I'm going to have 5 times 2 plus 4, or 10 plus 4, which is 14. So both lengths will be 14. If this makes sense to you, okay, please put a check. If you are struggling with this and you have questions on this problem, please make sure you put a big question mark next to that problem so when I'm walking around I can see that I need to assist you in this property. We will also have a quiz on the properties of all of these shapes on the 17th and 18th. So please make sure you are studying your properties. All right, so we have the rhombus golf here, and we're asked to solve for y, GO, and OL. So GO is a side length, okay, and so is OL. Remember, with a rhombus, all the sides are congruent. All sides congruent. That's the property I'm using. And again, really the only thing you can ever do with sides is set them equal. Or use Pythagorean theorem to solve for the diagonal. So just please keep that in mind. So our work, we're going to set each piece equal to each other, and we're going to solve. So I'm going to subtract y here from both sides. I'm going to get y minus 5, add 5 to both sides. So y equals 6. And then to get the side length again, you plug back in. So I'm just going to choose my easy one. 6 plus 1 is 7. And those sides were equal. So I'm going to plug it back in. Please show me that you are listening to this video and solve for the second one, plugging 6 back in, and show that you get 7. Right, our third example here, we're labeling the square, and we drew in the diagonals, and we're saying that angle CRS. If you struggle to know which angle is which, please make sure you draw it in. So there's CRS, 4x plus 5. And angle ORS is 3x plus 15. Now there's two ways we could go about solving this. We know that squares have right angles in all of the corners, okay? And we know that the diagonals bisect. So we know that each of those pieces should be equal to 45. So we could solve it that way. We also know that when they bisect, they're bisecting those angles, so they would be equal to one another. And that's the property that I'm going to use here to solve for x. But we already know what the measure of CRS and ORS should be because this is a square. They should be 45 degrees. So we're going to check that theory here. Okay. So I'm using that diagonals bisects the angles. Okay. And I'm going to set my pieces equal to one another. So I'm going to have 4x plus 5 equals 3x plus 15. And I'm going to move 3x to the other side. So I get x plus 5 equals 15. I'm going to subtract 5 from both sides. So x will equal 10. Okay, and I'm going to double check that it really does equal 45 so that you believe Miss Brown and I'm not lying, that on squares it will always be 45. So I'm going to do 4 times 10 plus 5. That looks like a 16. So I'm going to get 40 plus 5, which is indeed 45. Again, you could have solved this by just setting each piece equal to 45 and getting your x. For our last example here, we are looking at a rhombus again, and we have the diagonals drawn in. So I know that ATK is x plus 10, and I know that APB is 4x minus 35. This problem here is very similar to the last problem we just did for the square. Okay. Again, the property we are using is that the diagonals bisect each other. Or not each other, they bisect the angles. Okay, so I want you to work this problem out, okay? Make sure you circle all of your answers and you have shown all of your work, and I'm going to check to see how you do in class, next class, okay? Please come with any questions that you might have. Circle anything that didn't make sense so we can talk about it in class and get that taken care of. Again, reminder, we will have a quiz on the properties, the 17th and the 18th. Okay.